All right, I would like to know the percent composition by mass, and that's what we're going to be looking at, for potassium cyanide. So that means I want to know what percent by mass is potassium, what percent is carbon, and what percent is nitrogen. When it's all said and done, those percentages should equal about 100. You might get 100.2, 99.7. That just is a rounding issue. No big deal. So what you have to do is find out the mass of these. I'll tell you right off the bat, potassium is 39 on the periodic table, 12 and 14. So don't forget, for each one, when you go to figure out percent composition, you can keep calculating, I'm going to babble. When you do percent composition, it's going to be the part over the whole times 100. And that'll give you percent composition. So the part in this one is potassium over the weight of the whole thing times 100. So this is 39 on the periodic table. There's one carbon. It's 12. And this is 14. Do the math at 65, right? So 39 over 65 times 100. This one would be, it contributes 12 to the total weight of 65 times 100. And this is 14 over the total weight of 65 times 100. Has anyone got the percentages yet for these? Sure. The weight of the whole thing, yep. Yep, whole is the weight of the whole thing, of which there's 39 that came from potassium in that whole. Yep, Erica? You can have a point something, that's fine. You can round, but well, you should need at least one decimal point for these. Potassium, what percent did we get for that? Andrew, what did you get for that? 60%. Carbon was like 18 or something? 18%? Okay, 18 point, whoa. Messes up everything. 18.5. And then this one was okay. These are correct. Add them up, you're going to get 100%. Once again, it doesn't have to be exactly 100 because of the rounding, etc. That's percent composition. We've done this before. This isn't, Aiden, you got to stop this. We've done this before. The next step is the following. Using percents to figure out something called empirical formula. This is what we're really doing. We want to determine, so determining the empirical formula of a compound or molecule. That's what we're going to be doing. There's one word that can solve the whole thing, I think. It's not a real word, or maybe it's two words. It's not real, but it gives you the sequence that you have to use to figure out the empirical formula. But of course, the first thing is, I have no idea, you might say, what in the world the empirical formula is. So, let's do that. Empirical formula is the lowest ratio meaning you can't reduce anymore, the lowest ratio between the atoms of a compound or molecule. And I'll give you an example, and I think that can help a lot. Compound slash molecule. It's the lowest ratio. Something like this. Back in bio, in the land of bio, remember what that was? C6H12O6? It's a sugar. It's a single sugar. It's glucose, or fructose, or dextrose, or galactose. There were 4 sugars that I taught in my classes. They are called isomers of one another, meaning they all have the same setup. 6 carbons, 12 hydrogens, 6 oxygens. They're just arranged differently. All the bonds fill and everything. They are the simple sugars, monosaccharides from bio. Well, what I'm going to tell you is this the empirical formula for that molecule? Is that my lowest ratio? Or can that be reduced? C1, H2O1. We can divide this all by 6. So then we'll get C1, H2O1. That is its lowest form. That is the empirical formula. You don't need the numbers. So really, the correct answer is this one. And I'll scroll it up. CH2O. That is the lowest ratio for the compound. Looks like that. Okay? I'm going to tell you that there is a way that if you know how much carbon contributes toward the molecule, or any element contributes toward the whole compound, if carbon contributes a certain amount, and hydrogen a certain amount, and oxygen a certain amount, for this one, by weight, you can figure out what the empirical formula could be. For example, if I took, let's see, if I had 65.5% of carbon, and I have 5.5% hydrogen, and I have 29.0% oxygen, that's all by mass, you will be able to, when we're done, you will be able to take this and tell me the right ratio between the carbons, the hydrogens, and the oxygens for this example. Okay? In the lowest ratio. This isn't the answer yet. It could be 1 to 1 to 1, but it may not be. So here comes the word of the day. This, believe it or not, is vital. This is something even in AP Chem. I'll start talking about it, and they'll say the word for the kids I've had. Here's the word. Pig. Write it the way I write it also, please. Motor. M-O-D-E-R. Each letter means something significant, and the order that they come is crucial to figure out the empirical formula, that lowest ratio, if I give you the percent. Now, I'm going to go through an example and we'll look at each letter, and then I'll actually write the P means this, the G means that. So you don't have to worry about it too much. So, the example I'd given to you was, well, let's do this. What if I had, I'll do a different example. What if I had this? I had 89% oxygen. And I also had 11% hydrogen. I know we just did this one, but I want to show you how you can solve for what the ratio would be. The next step is the easiest step you'll ever do in my class. You're going to go from the percent which is given. 89% of that molecule is from the weight of oxygen. 11 is from hydrogen. Easiest thing going. You're going to go from percent to grams. Gee, how do I do that? Right there. I'm in grams now. I'm in grams. Easiest thing going. You just make percents grams now. That's all you do. Okay? Now we are going to go, and this is why we talked about, and we just wrapped up a whole section on moles. We have to go from grams to moles. To go from grams to moles, you're going to be dividing by its weight on the periodic table. Oxygen has 89 grams. That's what we just said. And oxygen weighs 16 on the periodic table. So you divide that. Actually, you just, well, yeah, you get moles with it. And then hydrogen is 11 grams. What's hydrogen weigh on the periodic table? Yep, 1. So this is 11. And this I don't know yet. 5.5. Five and a half. I'm in moles right now. I have 5.5 moles and 11 moles. I'm right here in my pig motor thing. The D is for dividing. Once again, I'll write these out with you in a minute. You're going to divide by the lowest number that you have for moles. I'm only using 2 elements. I could have 5 of them. You choose the lowest number. So the lowest number is going to be 5.5. And when you do this out, you're going to get a 1, and that's a 2. It just so happens that they're nice, even, pretty little numbers, because the R would be rounded off. If you have a decimal or whatever, you round it off. You round it to the nearest half. That means it's either going to end with a 0 or a 0.5. Something like this. If I have 1.35, if I had that, I don't, but if I had that, is that closer to being, when I say round to the nearest half, is it closer to being 1.5 or 1.0? 1.5. What you need to think about is, okay, this is as if it's 0, this is as if it's 50. Well, 50 and 0, the midpoint is 25, and that's above 25, so it's closer to the 1.5. This one does not have that problem to it. Some I give you for practice will. So when you get to the round, you round to the either whole number or the half number, whatever one is closest. So what I'm going to do is, the rounding doesn't need to take place because it's already zeros. I have my answer. These numbers mean something to me. What it's going to mean is, in my compound of oxygen, I have 1 oxygen. And in my compound of hydrogen, which is what I started with, I have 2 hydrogens. I have H2O. Okay? So we went from knowing the percent by mass that it contributes, or the weight, to figuring out what must the compound look like, its lowest ratio. Okay? So this is what I'm going to do. I have a practice problem. I gave it to you earlier. It's right up here. Could you please try to solve this one? 65.5% carbon, 5.5% hydrogen, 29.0% oxygen. Keeping in mind that pig motor thing. Percent to grams, that's a piece of cake. Grams to moles means you're dividing by the weight on the periodic table. Then you divide by the lowest number of moles, and then you round. I'm sorry, I didn't tell you this thing. So P is for percent. Just so you have something. G is for grams. M is for moles. D is for divide by lowest mole number. And then the R is round to the nearest half, the nearest 0.5, which means it could be a whole number. We'll say 0.5 or a whole number. So it's either going to end in a 0 or 0.5, whatever it's closest to. So that's what this is. I'll post a video later on today up on our website. So if you forget it, fine, because you do have some problems to do tonight for homework. But that's what this does, and here's the problem I'm asking you to solve right here. 65.5% carbon, 5.5 hydrogen, 29.0% oxygen. Why don't you take some time and do that now, please? Okay, let's take a look. The way we're going to do it is this. I'm looking for the empirical formula. in figuring out the empirical formula, I know I'm going to use this little mnemonic thing, pig motor. I have to go from percent to grams, right? So that's the easiest thing going. I set them up like this. I'm going to say, all right, percent to grams, I know I have 65.5 grams of carbon. Then I skip a little, and I'll do the next one, because I'm going to do the math going across, left to right. Then I have 5.5 grams of hydrogen. And then I have, 29.0 grams of oxygen. So I've gone percent to grams, and that was simple. Grams to mole was a division. You're going to divide by the weight on the periodic table. So carbon weighs 12. I'm going to get an answer. Hydrogen weighs 1. Oxygen weighs 16. Are we okay so far? Now, when I do the division, I will know my answer in moles. So 65.5 divided by 12 is 3.02. I'm a math genius. 5.5 divided by 1 is 5.5. I'm a math genius. 29.0 divided by 16. Wait. All right, I have time. Okay, I've been corrected. I'm not a math genius. This is 5.5. I'll get better. And this is 1.8. All right. I am now up to, I have moles. The D is for what? What do I do? D. Divide what? Nice. I divide by the lowest mole number. Thank you, Fricky. So, lowest number, I messed this up last period. I did the 5.5. It's 1.8. When you do this, you're going to get 3.02. Then you're going to get 3.03. And obviously, one of them will be 1. Am I done? No. I have the R left. I have to then round. I have to round to the nearest half, or a whole number. 3.02 is closest to being 3 or 3.5. It's a question.
3.
Thank you. 3.03.
3.
And then 1 is just 1. Here is what it's telling us. I have 3 carbons. So I have C3, H, I have 3 hydrogens. There's my final answer. H3, and for oxygen I have 1. So the answer is C3H3O1. Given the percent I gave to you, the molecule must have a ratio of this. 3 carbons, 3 hydrogens for every 1 oxygen. Okay? That's how we solve them. So, let's do some problems.